This video demonstrates how the prototype SketchingMetal system can be used to gesturally create a parametrized 3D model from which a complete manufacturing process can be derived to produce a precise, fully detailed metal part. The user begins by gesturally drawing a two-dimensional framework for a three-dimensional part. This framework is composed of lines, points, and circles. In addition, the system infers a variety of geometric constraints between primitives as they are drawn. Here the user insets one line and then repeats that operation for a number of additional lines. All of these lines are constrained to be inset by the same amount. The user continues the construction by identifying key intersection points in the 2D drawing. Then the user deletes the lines that define the intersection points in order to draw more precise line segments. However, to abstract away the notion of wall thickness in this part, the user can interactively define a piece of geometry to act as a slider. This is done by drawing a point on a line segment. By dragging the distance value of this point and dropping it on the number representing the inset line distance, the slider controls all of the inset lines simultaneously. Next, the user draws a pair of identical circles tangent to two lines, followed by two more circles, again tangent to two lines. Another slider is created to control the size of the second pair of circles. To set the dimension of the second circle pair, the user first equates both pairs by dropping the radius value of one onto the other, and then subtracts the wall thickness by dropping its value onto the subtract box for the second pair. The user now has a high-level parametrized 2D construction. To extrude this two-dimensional model into 3 dimensions, the user first draws an approximate outline curve. This curve is then automatically snapped to the 2D model primitives to make a smooth, precise curve. The outline is then extruded into 3 dimensions by drawing a line segment off of the drawing plane. To continue the 3D construction for this part, the user needs to subtract 3 pockets from the extrusion. This is done by drawing 3 approximate curves which are snapped again to features of the 2D construction. Then all 3 pockets are subtracted from the extrusion by drawing an axis downward. All 3 pockets will be created to have the same depth. At this point, the user can interactively control all the high-level variables for the parametrized geometric part. This form of interaction is often helpful to gain understanding of design variations. However, most parts will require precise numerical adjustment. This is done by typing a number on top of any dimension value in the model. In order to manufacture this part, the user only needs to specify one more thing, the location of 2 fixture holes. These holes enable the outer profile of this part to be manufactured. The user pops up a window to show the fully detailed feature-based version of this model that the system has been maintaining all along. This feature-based model completely specifies the entire manufacturing process. The 4-step manufacturing process starts by planing the stock of metal to the approximate dimensions. Then, interior details are milled out, followed by drilling holes for a fixture plate to support later operations. The fixture plate is then attached, and finally, the outer profile of the part is cut now that it won't interfere with the vise. The machinist will then take the final part and clean it off and send it back to the original designer. In this example, the entire process from initial art to final part takes less than a day.